I just read Deepseek's entire technical report, so you don't have to. Today, you're going to learn exactly why Deepseek's reinforcement learning architecture is more performant than OpenAI, Gemini, and Claude at a 96% cost reduction. We're calling it Deepseek R1 for Dummies. If you don't have time to watch this video, make sure you guys save it down below and give your boy a follow. I do appreciate it. All right, large language models fall under machine learning as it relates to computer science, and machine learning is a subset of artificial intelligence that enables computers to learn from data, improve their performance over time without explicitly changing the underlying program. This is basically like object detection. Basically, if I have a picture of 1,000 puppies, the algorithm will know that it's a puppy. If I have a picture of 10,000 puppies, the algorithm will really know that it's a puppy. This technology was pioneered by Ilya Sutskever, who sold it off to Google, who then joined OpenAI, who then has now left OpenAI, and now nobody knows where he's at. But yeah, that's how that happened. From machine learning, large language models can be architected with a SFT approach, supervised fine-tuning, that's what OpenAI used, or a reinforcement learning approach, and a subset of reinforcement learning, reason-oriented reinforcement learning. That's what Deepseek did. Okay, to put it to you quite simply, supervised fine-tuning is very, very heuristic heavy, meaning that a heuristic is a shortcut. An example is, let's say we go to the grocery store and we want to check out fast. Well, if you want to get to checkout fast, you usually go to the shorter line. But that doesn't necessarily mean that that line is going to give us the fastest way to check out. Because what if that line is occupied by an old lady who's counting a bunch of coins? Well, then that heuristic, yes, go to the shortest line and check out faster, works sometimes, but not all the time. That old lady is counting coins. Meanwhile, the second line here has two people in it. Yes, it seems like it's longer, but one person's buying a bagel and the other person's buying a Plan B. That would have been the better line to go down. If we would have used chain of thought, then we more than likely would have been able to figure out that that was the line we should have chose. Unfortunately, supervised fine-tuning doesn't choose that line. Supervised fine-tuning is heuristic heavy. And we know that because OpenAI got in trouble along with other frontier model builders because they were using human feedback to fine-tune their models. They hired thousands and thousands of people in Africa. I suggest you guys go watch this little documentary here. They hired thousands of people in Africa and other developed nations to fine-tune their models for them. Okay, so that is very cost-intensive, and of course, it gives you a very rigid model. Now, O1 and O3 more than likely uses reinforcement learning, but we don't know that because those models are closed source. We do know for sure that OpenAI was using SFT. Meanwhile, Deepseek was using reinforcement learning. Let's break down what reinforcement learning is. Reinforcement learning has 5 core elements: an agent, an environment, a state, and an action. Let's think of this in terms of playing a computer in chess. The agent is the computer, the environment is the game of chess, the state is the current position of the pieces, the action is either the computer waiting on you to play or the computer processing its next move, and the reward, well, the reward can't be as simple as win the game, because in that case, you will get a lot of false positives. What if you try to get a pawn to win the game, but you got that pawn with the queen, leaving your queen exposed? So you have to create what's called shaped rewards, where basically the reward system is going to have different weights. Material gain loss is going to be scored higher. You have positional rewards, king safety, center capture. There's going to be a bunch of different rewards inside of the chess reward system. This is how reinforcement learning works at its best. You design a reward system that encapsulates all the variables of the environment, so that way you can run a system, and through running the system millions of times, called a Monte Carlo simulation, you then eventually get a well-trained model. And I mean millions upon millions of times, oftentimes billions of times, right? But what is reasoning-oriented reinforcement learning? This is the system that Deepseek used, and this is the way that they were able to save 96% on their compute. Don't believe me? In the first paragraph, they mentioned their zero model, a model trained via large-scale reinforcement learning without supervised fine-tuning. They didn't use SFT. They basically let the model be a baby, bump around a bunch of times through Monte Carlo simulations, and improve itself over time. But they had to set the parameters, and one of the key parameters was a thought. So this is how it works. Basically, thinking scored a point. Thinking a lot scored more points, thinking bad thoughts scored less points, and getting the correct answer scored a lot more points. And this is the visualization of that. It also even mentions here, this diagram is from the paper, Deepseek R10 naturally learns to solve reasoning tasks with more thinking time. So they were rewarding the thought. they weren't rewarding the correct answer. And that's exactly why they were able to get such a high performing score with such little cost, as opposed to OpenAI and friends who are going out to sub-Saharan Africa or different third world countries and having human feedback create the model. They were using a more technical approach. Now, there are many more variables as to why DeepSeek is so performant, but that is one of the key reasons. Okay, I actually have it listed here in terms of their cost reduction strategies, and I'll be going over this massive diagram that I've created over the next couple of days. So make sure you guys follow me as I piece this thing apart for you.